For the flight simulator group, our problem statement was to further improve and make the simulator as realistic as possible. Our main goal is to make the simulator an overall more professional teaching aid and fully functional simulator that replicates real flight, as well as having the interior fully equipped and replicate a real plane cockpit. Some of our mentors included our instructor, Mr. Sutcliffe, a professional from Garmin who helped us out with our Garmin panels, Mr. Bader from Sega, Mr. Matt Miller, who is a private pilot instructor for Scott Inman, and Mr. Inman, who flies for American Airlines.
Hello, this is Scott Inman. I'm a member of the Flight Simulator Project. Right, right now we're interviewing Mike Inman. Throughout the project, he's been a mentor for the Flight Simulator. He's kind of talked to us a little bit about the training process and just general aspects of the simulator. He's also visited us at the CAPS program. He came and looked at the simulator itself. Kind of just talked about it and how we can improve it, and kind of just a couple aspects of the training process. My first question for you today is your occupation currently and what experience you have.
I'm currently a pilot for American Airlines. I fly the Boeing 767. I've been employed there for 30 years as a pilot. Before that, I flew corporate aviation and charter and flight instructor.
All right. So do you have any experience with simulators currently?
Yes, I've used simulators for the past 30 years. In fact, we exclusively use simulators today. 25 years ago, we did do some training in an airplane, but nowadays, with the complexity and the realism that you find with the newer simulators, we do all of our training in simulators.
So what experience do you have with instructing students and professional pilots?
Well, I started flight instructing while I was in college, and I did primary flight instruction when I was in college, all the way up to instrument instruction and multi-engine instruction. After that, once I was employed at American Airlines, I became a check airman instructor pilot there, and did both simulator and what we call line or real world flying instruction.
Can you tell us a little bit about how you guys use simulators in the real world as an instructor and just currently as a pilot?
Sure. We use simulators, like I said, exclusively. In a normal simulator session, basically starts with a briefing. Usually that briefing will last 2 hours. And what you'll do is you'll go over everything that you're going to be doing in the simulator. So there are no surprises really. This cuts down on simulator time. Simulators are very expensive to operate. So they're an expensive piece of equipment, and we try to minimize the time that we stay in the simulator to get to be as efficient as possible. After the briefing, you go into the simulator. You'll fly your maneuvers, mainly consisting of approaches and emergency procedures. And then after the simulator period usually lasts around 4 hours for 2 pilots to go through. After that, you'll debrief for anywhere from 15 to 30 minutes, talking about mistakes you may have made, what you can do to do it better. Instructor will put his input in on how you can do things better.
All right. Can you tell us a little bit about how you helped us with the Flight Simulator project and what critiques you had for maybe some of the teaching process aspects you had?
Well, on my visit to the CAPS program, the day I was there was discussions going on about the glare shield in the simulator, and I tried to lend a little advice on how that glare shield should be positioned and set up. In addition to that, I've kind of advised Scott at home in regards to procedures and how they're written and how procedures are used in a simulator.
All right. I'd say you've been a great mentor for our project. You've helped us with the teaching process and many aspects for the simulator. We'd just like to
Before we started on our main projects, the previous year had an electrical surge go through the system, which broke the throttle quadrant in the autopilot. Our goal for the throttle quadrant was to make the original piece from the original plane fully functional. For the autopilot, our goal was to order a new autopilot and install it, taking full advantage of the SciTech autopilot component.
Hi there, I'm Scott Inman. I started on the simulator project this semester. I'm just going to be talking to you guys about what I've done on the project as a group and individually. Individually, I've worked on the throttle quadrant alongside with Addie Hewlett. Personally, I worked on the glare shield. I designed it, and I kind of just elaborated on how I'm going to finish it and put finishing touches on it. Right now it's still in the process of getting done. The foam cutter is currently down, so I'm having some troubles continuing on that project. I'll probably have the next semester group work on it. The next step I worked on was I kind of just dabbled in it a little bit was the Garmin panels. I started working on those with Gus Nelson. We were just kind of learning how to use them a little bit before the Garmin people get back to us with the actual working Garmin panels, and that way we know how to use them when they get here. Another big project for myself is the teaching process. The teaching process for me is a big part because I'm currently working on my my private pilot's license. I've got about 30 hours, and my goal is about 45 or 50 hours to get my private pilot's license. So that will help the group a lot, I think, with the teaching process, and in the future it will kind of teach future students on how to use the simulator and how to fly the simulator.
Hey, I'm Gus Nelson. I started on this project a little bit late, but the very first thing I did was learn how to fly, which was pretty cool for me. The first main project that I started on this was the autopilot. I helped build a mount for the back of it, so that way we could mount the original system on there and replace the old broken one. We built the mount and put it right back onto its original spot in the main instrument panel. The next thing I really did was help Scott Inman with the foam cutter. He had major issues trying to transport the file into it, so that's what I did with some of the techie stuff, was to try and get that file in and get it fixed and working. Some of the other techie stuff I did was work with the X-Plane 10 system, and we helped update the file system, just simple tasks like that.
Hi, I'm Ryan Sherwood. I'm a Blue Valley Northwest senior. I worked a lot on the autopilot. That was probably one of my more main projects. I helped design the mounting that we use for the autopilot system, as well as some of the ideas on how to use it, as well as creating a more instruction sheet on how to use it if you're just beginning to learn the autopilot. I also worked on updating the flight simulator program, X-Plane, to the next level with the help of Mr. Sutcliffe. So that was really fun. I also worked a lot on, we started looking into the throttle quadrant because we wanted to try and make that usable as well. We didn't get quite as far as we did with the rest of the project on that, but that was something that we were working on and I was active in helping out with. I also helped out Scotty a little bit with the dimensions of the glare shield when he had to saw out the base for the foam for the glare shield to go onto. So that is what I did for the project.
Hi, my name is Addie Hewlett. During my semester at CAPS, I've been working alongside Scott Inman to develop a teaching process that could be used by intermediate or beginner students. We developed a few different processes that could be used both by teacher and student. Some of these included a normal takeoff, a landing, and a taxi process. Personally, starting off with not having any knowledge about how to fly, our processes that we developed really helped me start off on how to learn how to fly a plane, in which I could go out into fields and really have a basic grasp on knowledge on how to fly. Also, finally, I developed a protective case for the throttle quadrant with Scott and the manufacturing consultancy section of CAPS. We came up with a little box that would help our throttle quadrant chip, which had a shortage a few years ago, so that nothing else would happen to it and no other shortages could affect that. So basically I came up with some dimensions and went to manufacturing consultancy, and they came and confirmed those, and then they 3D printed us the box and we installed it onto the throttle quadrant so that nothing else could ever affect that, and that we wouldn't have to buy another chip for any previous years. And that's what I've done this semester.
Hi, I'm Reese Crawford from the simulator team. I did the work on the ventilation system for the simulator. So the three goals that we came up with for this project were to make it as realistic as possible for the pilot, comfortable as possible, and also cosmetically appealing. So as far as making it comfortable goes, we threw around the idea for an AC system at the very beginning of the year, and then quickly said that that wouldn't be feasible for temperature control, but we could still do a ventilation system. So I reached out to Sega, and we talked a little bit on what would need to be done, and they gave me a formula that was took like 2 pages of math to figure out, and we got it done. But it figured out how powerful of a fan we need to move stuff around. So that was 250 CFMs. CFM stands for cubic feet per minute, or how much like volume of air is moved by the fan per minute. And because it was 250, we decided to overestimate that because we have some small pipes and flex duct that has to work through. So we bought a 270 CFM, again cubic feet per minute fan, installed it to flex duct. The flex duct links up to the existing ventilation system on the aircraft. Now in the summertime, that flex duct system with the fan can be dropped into the CAPS HVAC system, their heating, ventilation, and air conditioning. And then in the wintertime, that can just be pulled out, and it can pull air through it. And the room temperature air in the wintertime is just fine.
The glare shield was another one of our side projects. The idea was thought of by looking at the original cockpit from the King Air A90. In the real King Air, it blocks sun from reflecting into the pilot's eyes and making it hard to see the instruments. In the simulator, it is purely aesthetic. Another one of our side projects included the teaching process. Our goal was to make the teaching process so we could teach students and the general basics of aviation. So far, we have taught several students, parents, and other administrators, as well as faculty members. Here you see some data from our teaching processes. Overall, our success rate was very high, reaching most of the students who we taught, except for a few failures, including Kyle Welch. Another one of our side projects included the Garmin panels. The Garmin panels were donated to the project to make the simulator more advanced. Since then, Garmin has helped and is currently helping us make the panels fully functional. Once operational, we plan to learn how to use the panels to their full potential. We have already started learning through an instructional video and following along with the computer stimulated panel. However, Garmin's panels are so advanced they're not in commercial, only private planes. Our final side project included the air conditioning unit. This project has been one of our side projects for the group, in which we have had several mentors help us. We assigned one of our group members to work on the side project while we finished up on other projects on the simulator. Our goal for this side project was create ventilation for the simulator as it gets hot in the simulator after long periods of flight. Our plan was to install fans and piping to the simulator's insides. For the future, we hope the simulator continues to advance and become more of a better training tool. We have some ideas that may develop for the simulator project. We hope that in the future the teams will work on the glare shield, Garmin panels, air conditioning unit, teaching process, and make the throttle quadrant fully functional. We achieved a lot of our goals and we are very happy with the progress we have made on the simulator. We finished several projects and as well as started many projects for the groups to come after us. The members of our group love the simulator project. We would highly advise future CAP students to get involved with the simulator project. It was very fun and we learned a lot.